Okay, so in this video we're going to take a look at a couple example problems that are going to allow us to put the information from Section 5 to use. If you recall, Section 5 taught us about HL congruence. And HL congruence was a way that we could prove triangles congruent that said that if you have right triangles with congruent hypotenuses and a pair of congruent legs, then they are congruent. So right triangles with congruent hypotenuses and a pair of congruent legs are congruent triangles. So in our first example it says, what other information would be needed in order to use the HL theorem to prove that the two triangles below are congruent? First of all, we notice that they are right triangles, so we can use HL. That's like the first requirement for using HL, is that you're looking at two right triangles, and we are. So then we can just kind of go through this definition and ask ourselves, do we know that they have congruent hypotenuses? Well, the hypotenuse of triangle LMN would be segment LN, which it says is 9 units long. The hypotenuse of triangle PQR would be segment PR, which is an unknown length. So we need that length of PR to be the same as the length of LN, which means it needs to be 9 units long. So I would need to know that this is equal to 9 units. Then I would need to have a pair of congruent legs. I notice that segment QR is a leg of triangle PQR and it is 5 units long. Well, I would need one of these two legs to be 5 units long. Now, that looks to me like the shorter of these two legs, just like MN is. So I'm going to say I need MN to be the same length as QR, which means it's going to be 5 units long. So this would be 5 units long. And if I had those two pieces of information, that this was 9 and that this side was 5, then I would have two right triangles with hypotenuses that are congruent, they're both 9, and a pair of legs that are both 5, so those triangles would be congruent by HL. In the second example here, we have a little bit of a proof that we're going to explain why in this picture, why is segment JM right here definitely congruent to segment LM. And the clues that I can see they're starting me with is that I have a right angle here, and I have segment JK congruent to segment KL. So let's think for a second. What would make segment JM congruent to segment LM? Well, I notice that they are both parts of two different triangles. They'd be like corresponding parts of a couple different triangles. They'd be corresponding parts of triangles JNM and LNM. They'd also be corresponding parts of triangles JKM and LKM. If I can prove one of those two pairs of triangles congruent, then I could use CPCTC to say that these two segments would have to be congruent as well. Well, what do I know so far about, let's look at triangle JKM and triangle LKM. Do they have any parts that are congruent between them? Obviously they have segment JK here, congruent to segment LK, and they share segment KM. So they do have at least two pairs of parts that are congruent between triangle JKM and LKM. If I could get a third pair of parts that are congruent, then that would, specifically it would have to be either the third pair of sides, which doesn't seem to make sense because that's what I'm trying to prove anyway, or maybe the angle that's between the congruent sides. Then that could be maybe SAS, that would make triangle JKM congruent to triangle LKM. So is there any reason why this angle has to be congruent to this one? And then we start looking at why is this clue here. If this is a right angle, so is this one. And then triangle JKN, this triangle right here, and triangle LKN, so this triangle right here, LKN, those would be two right triangles. And I see they have congruent hypotenuses, and they share segment KN between them. So I think those two triangles are congruent by HL. And if they're congruent, then these angles here would be congruent because they're corresponding parts. So here's what I think I'm going to do. I'm going to say that segment JK is congruent to segment KL. That is given. And I'm going to say that segment KN is congruent to segment KN. It's congruent to itself. And that is by the reflexive property. And then I'm going to say that triangles, I'll say it this way, triangle JKN and triangle LKN are both right triangles. Therefore, because this is the hypotenuse and this is the leg, therefore triangle JKN is congruent to triangle LKN by HL. Now, if that's true, then angle JKN is congruent to angle LKN. Angle JKN is now congruent to angle LKN because of CPCTC. The corresponding parts of congruent triangles are congruent. Then I'm going to say segment KM is congruent to itself by the reflexive property. And that means that triangle JKM is congruent to triangle LKM by side, angle, side. We're using this side here, we're using this angle here, and then this side right there. And then finally I can say segment JM must now be congruent to segment LM by CPCTC. And so that's a pretty tough explanation to kind of make your way through, right? We first had to prove that these two triangles were congruent so that we could use this angle and this angle to prove that triangles JKM and LKM were congruent, so that finally we could use CPCTC to say that these two segments were congruent. That was a tough little proof. And that's maybe about as hard as we're going to get until we start looking at some triangles that are going to be overlapping each other, and that's going to be the subject of one of our next videos. Okay?